Again, 2 3 points are there related to the dispersion of light. Which that 2 3 points are there, that one will see. First thing is there, Sir Isaac Newton. Sir Isaac Newton first time Sir Isaac Newton used glass prism to obtain spectrum of light. So who was the first scientist to use glass prism? Sir Isaac Newton was the first scientist and who used glass prism to obtain the spectrum of light. Second thing is that in that white light enters, when white light enters into the prism, different colors bend in different angles. So next thing is that when white light enters into glass prism, different colors bend in different angles. Then next point is there, what you can say, red color bends least and violet color bends the most. Red color bends least means less, and violet color bends the most means maximum. And last point we can say, 7 colors emerges along the different paths, and they get separated and they are forming spectrum of 7 colors. So 7 colors emerges along different angles and get separated and forms spectrum of light. They are forming spectrum of light. Band of 7 colors, they are forming spectrum of light. So next thing is there, use your brain power. In that 2 questions are there, so just we'll discuss on it. First question is there, by using 2 prisms, use your brain power in that. Use your brain power in that 2 questions are there. Which 2 questions? First question is there, by using 2 prisms, how will you obtain white light? By using 2 prisms. So if you are using 1 prism, then 7 colors you will get, band of 7 colors. But how you will obtain white light by using 2 prisms? So it is simple. What you have to do, question is there, by using 2 prisms, how will you obtain white light? So simple it is. First thing is there, suppose this one is 1 prism, one prism number 1, prism 1 suppose. So what will happen? Light will travel. Suppose here normal is there, light will travel, and incident light ray will be there. Then here after this incident light ray, then it will get refracted, and again it will get separated into 7 colors. Again it will get separated into 7 colors. But this one is the incident ray. Here will be red, here will be violet, here will be red, here will be violet. Then what you have to do now, you have to place one another inverted prism. You have to place one another inverted prism. Okay, we'll do one thing, we'll keep close. Suppose light ray will pass here. Here will be red, here will be violet. So you have to keep one glass prism like this way. Then what will happen? This light ray will fall here. It will be incident now. So that light ray will get refracted. It will go like this way. It will bend. Again from here, again it will get refracted. So what will happen now? Here is the white light. Here separation of color will take place, and when that light is passing to the another prism, suppose this one is the prism number 2, prism 2, then what will happen? This one will be white light. So you can obtain white light by combination of two prisms. So here you can write, we can obtain white light by using combination of two prisms, keeping another prism inverted upside down. Okay, so this one is there about what you can say, obtaining white light by using two prisms. So after this, one more question is there in the use of brain power, and that question is there about chandeliers. In the chandeliers you are knowing, in Marathi you are saying Zumbar. Whatever, suppose your house is there, and in that you are using like this way, decorative material is there, like this way, chandeliers is there. Suppose here middle. So, and here you are fixing one bulb. And it will light will emerge out. But here different prisms you are using, and related to this one question is there. So what is the question? So that question is there, in the chandeliers, if you are using tungsten bulb, then you are getting a light will get refracted and you are getting colorful effect. And if you are using LED bulb, then why you are not getting that particular colorful effect? This is the question. Question is the question number 2. In chandeliers, we get the effect of colors by using tungsten bulb, but we do not get that effect by using LED bulb. So what is the reason for it? The reason we have to find. Reason is there. So what is the reason? Just give attention. In case of the tungsten bulb, what you can say, intensity of light remains same, but in case of the LED bulb, intensity of light will not remain same. So reason is very simple. In tungsten bulb, or a light emitted by tungsten bulb, in light emitted by tungsten bulb, light emitted by tungsten bulb, intensity of light remains constant, but the intensity of light emitted by LED bulb does not remain same. So this is the reason. Okay, so in case of the LED bulb you will not get that effect, but in case of the tungsten bulb you can get that particular effect. So after this we are going to learn about next point, and that one is their partial and total internal reflection. Partial and total internal reflection we have to study. So partial and total internal reflection. Partial and total internal reflection. So what is the partial and what is the total internal reflection? That one we will take in a quick. So next point is the partial and total internal reflection. Partial and total internal reflection. So what is total and what is partial internal reflection? So explanation we'll see first, and then we'll write points. Listen, in case when light enters from a rarer medium to the denser medium, or suppose light enters from denser medium to rarer medium, that rules first will revise. When light enters from the rarer medium to the denser medium, then it bends towards the normal. When light enters from denser medium to the rarer medium, it bends away from normal. And third one is there, when light will fall along a normal, it will pass along the normal, then it does not bend. So these three rules are very important for understanding total internal reflection. So while writing points only, we'll take this one. So listen, when light enters from a denser medium to the rarer medium, then it partially get reflected. Some part is returned back, partially get reflected. That means some part is reflected back and some part is refracted. It will pass from one medium to the another medium. So we'll take diagram here, and with the help of diagram we'll explain. So one thing you have to remember, suppose one medium is there, suppose here one bulb is there, and this one is there, suppose this one is there, water or any denser medium is there, denser medium, water will be there, or any denser glass may be there here, and here is the air, So according to first rule, light which is traveling along the normal, that means here it will make 90-degree angle, so this light will go straight here, no problem. But another case you will take, when light enters from denser medium to rarer medium, then what is happening here? Suppose you take one normal, then light will travel, light would travel like this way, then here will be angle of incidence, then what is happening? This one is the incident light ray. Some part of light, it is getting reflected back, some part of light will get reflected back, and this angle of refraction will be same. So in case of the reflection, angle I is equal to angle R. This one we have studied. This one is there for reflection. Angle of incidence is equal to angle of reflection. So some part of the light get reflected. This one is the normal, suppose, and some part of light, remaining part, it get refracted. This one is the reflected ray. This one is the incident ray. So some part get refracted, that means it will travel from one transparent medium to another transparent medium, but this one is the denser medium and this one is the rarer medium. But we have seen that rule that when light enters from a denser medium to the rarer medium, then it bends away from normal. It will bend away from normal. So angle of refraction will be more. So when light passes from denser medium to the rarer medium, it bends away from normal. This one is the normal, it will bend away from normal. Next thing is the angle of incidence I is smaller and angle of refraction is larger. So angle of incidence I is smaller and angle of refraction, angle R is larger here. R is larger, I is smaller. So this one is there. This angle is the angle of, suppose, RF, angle of refraction you can take. Here two angles are there, RR, that's why we can write RF. And this one, angle of reflection. And refraction is there. The next thing is there, and if we increase angle of incidence, angle of refraction also increases. But according to Snell's law, sin I upon sin R remains constant. That means refractive index remains constant for two mediums. Refractive index is remaining constant for two mediums. So just give attention here. Suppose again we'll see light ray will pass here like this way. So here will be normal will be there. So what will happen? This angle of incidence now will increase. Angle I will increase now. As angle of incidence increases, again it will bend little bit away from normal. That means angle of refraction also increases. So this angle of incidence increases. As angle of incidence increases, here angle of incidence is less, and here angle of incidence will increase, then angle of refraction again it will bend away from normal. That means this one, suppose this one is the R1 and this one will be R2. Suppose this one is the I1, here will be I2. So as angle of incidence increases, angle of refraction also increases. But see, one more thing you have to remember. For a particular value of angle of incidence, suppose you will take next case here, next normal. So for a particular value of angle of incidence, suppose a light ray will pass like this way. Another light ray will pass like this way here. Suppose this one is the angle I3, angle of incidence I3. For the value of angle of incidence, for a certain value of angle of incidence, then this suppose I3 is there. For that I3, angle of refraction becomes 90 degree. That means light ray will pass like this way, 90 degree. Light ray will pass along 90 degree. So this angle of refraction, it will become R. Angle R will become 90 degree. At certain value, for the certain value of angle of incidence, angle of refraction becomes 90 degree, and that particular angle of incidence I3, it is called as a critical angle. So as angle of incidence is going on increasing, angle of refraction also goes on increasing. Okay, so for a particular value of angle of incidence, that is I3, suppose you will take, for that angle of refraction R will become 90 degree, and some part is again getting, this one is there reflected, this one is there reflected. So some part is reflected and some part is refracted. So we'll write about these points, and the next one thing we'll take, last case we'll take now. Here next case we'll take, here normal is there, and another incident light ray, suppose it will be incident like this way, this one will be incident light ray, and if suppose angle I4 is there, for that angle of incidence I4, so now angle of incidence is there, that one will be more than critical angle. When you are saying angle of incidence is critical angle, when angle of refraction becomes 90 degree, then it will increase again angle of incidence more than critical angle, more than I3, I4 will be more. So what will happen now? All the light ray will get reflected into the same medium. Here will be, now this one will bend like this way, then a light ray will get, or it will enters into the same medium, it will enters all the light rays. Now it will not pass from this medium denser to the rarer medium. So whatever light ray is there, it is totally getting reflected. So for when angle of incidence becomes more than critical angle, then all the light rays get reflected, no part of light is refracted, and it is called as a total internal reflection. So points we'll see. So first point is there, when light enters from denser medium to the rarer medium, then it partially get reflected. When light enters from, or light enters in rarer medium, from denser medium, then it's what you can say, it gets partially reflected, partially reflected, and the remaining part of light gets refracted. So first point you will understand, when light enters from, this one is their denser medium to rarer medium, when light rays enters in rarer medium from denser medium, then what happens? Some part of light getting reflected in the same medium. Reflection takes place in the same medium, and refraction takes place when light passes from one transparent medium to another transparent medium. Then first point should be clear, that when light travels from in a rarer medium from denser medium, then some part getting reflected, some part is refracted. Second point is there. In the second point, what you can say, when light passes from denser medium to the rarer medium, it bends away from normal. So when light passes from denser medium to rarer medium, then it bends away from normal. When light passes from denser medium denser medium to rarer medium, it bends away from normal. So see, this one is the incident light ray. When it passes from denser medium to rarer medium, it will bend away from normal. This one is normal, it will bend away from normal. So third point is there. In the third point, angle of incidence is smaller than angle of refraction. So here, angle of incidence is this one. Suppose this angle of incidence, angle I1 is the angle of incidence is what you can say, angle of incidence is smaller than angle of refraction. Why? This angle will increase, this angle is less. So what you can say, angle of incidence is smaller, angle of incidence is smaller than angle of refraction. What you can say, angle I is smaller than angle R, smaller than. This one you have to remember, this one is symbol of smaller than. Angle I is smaller than angle of refraction. Next thing is there, we'll rub these points. Then next fourth point I will write upper side. So I will rub this one. So one minute. Fourth point, if we increase angle of incidence, angle of refraction also increases, but according to Snell's law, refractive index sin I upon sin R remains constant. So fourth one is there, if we increase angle of incidence, that is angle I is increased, then angle of refraction, angle R also increases, but according to Snell's law, refractive index n is equal to sin I upon sin R is equal to constant, So what you can say, refractive index for two mediums, pair of the medium, this pair of medium, it remains constant. According to Snell's law, refractive index for the pair of a medium, if medium will change, then refractive index will change, but here these two mediums are fixed, that's why refractive index will remain same. Then next point is there, what you can say, for a particular angle of, now just see, if you are here, explanation of this one, if angle of incidence is increased, angle of refraction also increases. Suppose this one is there, R3 90 degrees there, here R4 is there, R4 will be there, angle of refraction. Then as angle of incidence increases, angle of refraction also increases, but sin I upon sin R remains constant. And the next thing is there, point number 5. Point number 5, for a particular value, of angle of incidence, suppose you can take for example I3, for angle of incidence I3, the value of angle of refraction becomes 90 degree, that is what you can say, angle R3 will be equal to 90 degree, then the value of, then what you can say, then the angle of incidence is called critical angle. So angle of incidence is called as a critical angle. That means critical angle will be the angle I3 will be critical. It will be critical. Angle I3 will be critical. Angle I3 will be critical angle. So next here we'll write by writing this one. 1 minute. So for critical angle, that means I3 is critical, angle R3 is there 90 degree, angle R3 is there 90 degree. So for critical angle, refractive index, this one, now just give attention, suppose this one is there, medium 2 is there, this one is there medium 2, and this one is there medium 1. Suppose this one is there medium 1 and this one is there medium 2. Then refractive index of first medium, that means air, with respect to second medium is equal to sin I upon sin R. But here for critical angle we are finding, so sin, we have taken critical angle I3, sin I3 upon sin R3. So here it is equal to what you can say, sin I3. Why sin I3? Because since sin of 90 degree is equal to 1, sin of 90 degree is equal to 1. So what you can say, for critical angle, refractive index n is equal to sin I. For critical angle, refractive index n is equal to sin I. n is equal to sin I. So this one, and the last point we'll see, this explanation is there. Now just give attention, critical angle here, if angle of incidence will be I3, then angle of refraction will become 90 degree. Then you are saying I3 is critical angle. And now next last point is there, if again angle of incidence is increased, angle I4 will be there. Then if angle of incidence is larger than critical angle, then angle of refraction will be larger than 90 degree. It will be larger than 90 degree, and all the light rays will pass, or it will get reflected totally. No part of light will get now refracted. So that point we'll write. Point number 6 will be this one. So 1 minute. Point number 6. If angle of incidence becomes more than critical angle, then angle of refraction also increases, and no part of light is no part of light is refracted. That is, all the light rays get totally reflected in the same medium, and thus it is called total internal reflection. So if you understand this diagram explanation, you can understand in a better way. So in a next video, or that one will be short video, okay, we'll take in this only. So next point is there, dispersion in that rainbow, effect of the rainbow we are going to see, effect of the rainbow. So what and how will be the effect of rainbow, we'll see. Rainbow is the combined effect of reflection, dispersion and refraction. So rainbow is the last point. So just give attention. First thing, rainbow is a beautiful natural phenomena. Second point is there, it is combined effect of dispersion, total internal reflection and refraction. So dispersion, total internal reflection and refraction. So next thing is there, we'll draw there. Okay, with the help of diagram we'll understand. So one thing, suppose one drop is there, drop of the water, and in this drop, this one is there, inside denser medium is there, outside rarer medium is there. Here is air and here is water. So what will happen? Light rays coming like this way from the sun. Suppose from the sun light is coming. This one will be incident light ray. When light ray travels from a rarer medium to the denser medium, then it bends towards the normal. It will bend towards the normal. So what you can say here, suppose like this way there, and if you draw here one normal, then a light ray will bend towards the normal like this way here. So here suppose point 1 will give here, point number 1. At point 1 refraction and dispersion takes place. Point 1 refraction and dispersion takes place. This one is the incident ray, and here refraction and dispersion takes place. Both things are observed. And here now, here we know according to laws of reflection. So here this light ray will go like this way and this light ray will go like this way. Then here total internal at point second, total internal reflection takes place. Now here point 3, at point 3 we'll see. So this one, these are the reflected light rays. These are reflected rays. And another thing is that when light ray enters from denser medium to rarer medium, then it bends away from normal. So normal will be like this way here. It will bend away from normal. This one will be normal. It will bend away from normal. This one away from normal. It will bend away from normal. And here also same thing. It will bend away from normal. So here refraction you can say. Here what takes place? Refracted light ray. Refracted ray. So this point is there 3. So at point first refraction takes place and dispersion takes place. Light rays will get separated. At point second, total internal reflection takes place. No part is refracted. And third one is there again when it will travel from denser medium to rarer medium, then it will bend away from normal, and then you will observe here, you will observe spectrum of the 7 colors, and here you will see band of the 7 colors. Rainbow you can observe here. Rainbow will be formed here. So this one is about rainbow. Now we'll see third point is there rainbow is seen after the rainfall. After the rainfall. Next point is there tiny droplets of water acts as small prisms. Act as small prisms. And last point will be there. So finally, thus a rainbow is a combined effect. It is a combined effect of dispersion, total internal reflection, and refraction. With the help of that diagram, one more time I will explain. Here incident light ray is there, then here it will get refracted and dispersed. Dispersion takes place at point 1. Then here at point second, total internal reflection takes place. No part is refracted. And here in third point, again reflection takes place, and the light rays will get separated, and you will observe color of the 7 or a band of the 7 colors. So this one is there about lesson number refraction. This lesson is over.